We have been tasked to create an airplane interface to notify the pilot of any significant changes in the altitude, the airspeed, as well as the state of the wheels. And we have indicators in the form of LEDs and the two gauges to notify the pilot of any significant changes.
To make this project a success, we needed Arduino Uno to interface between the computer and the LabVIEW software with the circuit that we've built on a breadboard. Also, we have two potentiometers that will act as the airspeed and altitude control sensors. We also have a dip switch which acts as the indicator that will tell us the state of each wheel. The states being either up or down. Also, we have LEDs that will alert us the current state, or more importantly, any dangerous states in the changes that are recorded in our indicators. As for the operation, noted in the current window on our front panel is that our wheels are all down. And this is also represented by this LED, which is on to indicate that all the wheels are down. This is also on our circuit represented by this LED, which is currently on. The LED over here represents the error, which is off, and this one over here represents the wheels, which should be on when all the wheels are up. Currently, I've just turned wheel 2 up, and now our LED reads that there's an error, also represented by the LED on our circuit. Once I turn all the wheels up, our up LED goes on, as well as the LED we have to represent all the wheels being up on our circuit. The LEDs over here are to indicate the dangerous states in our altitude and airspeed. This potentiometer acts as the altitude control. As the aeroplane picks up altitude, if it gets too high or the altitude reaches a specific point, an LED alerting the pilot that it's too high goes on, also indicated by this LED on our circuit. In an instance where the plane is now flying too low or dangerously too low, this LED goes on to indicate that the plane is now flying at a dangerous altitude, also represented by an LED on the LabVIEW interface. This potentiometer acts as the airspeed control, in which where the airspeed decreases, this LED goes on, alerting the pilot that the airspeed is too dangerous for them to fly carefully. Also, if the airspeed picks up and reaches a specific point, this LED will go on to represent that the airspeed is now too dangerous for flying.
While all this is running, the data is logged onto 3 Excel sheets every 10 seconds. Now we'll open up the wheels Excel sheet and view the data. This is all the data that has been logged since the program has been running every 10 seconds. Now here's the altitude, and lastly the wind speed.